Hi friends, this is Shomik Vishwas. So the continuation of the last day's lecture, we should start in this way, that for another problem we should take it as question number 3 here. One waveform is given just like this. This is 0, this is given as t by 2. This is a t-axis and this is a ft axis. Okay, is this visible? Oh, fine. So that is the problem. So you have to find out what is the expression of that whole waveform, what you should write for ft. That is the expression. So now what to do, see, this is a box function. Okay, this is a box function. So what is the dimension of the box function? 0 to t minus 2. So what should I write? That for the box function I can write it is u 0, sorry, that is g 0 comma t by 2. So it is equals to g of, sorry, u of t minus u t minus t by 2. Now if it is so what is the function? Basically this is obviously, if it is Vm, that peak is Vm, so it is Vm sine of omega t with that g of 0 comma t by 2. That gate function is ut minus ut minus t half. So that is equals to, you can write as Vm sine omega t ut minus Vm sine omega t u t minus t half. Okay, now you can do one thing, that you can write again that omega, you can write it again, that Vm sine of omega t ut minus Vm sine of that omega t. It can be written as, say, if I am taking omega out, so it should be 2 pi by capital T, this omega, and the t can be written as t minus t by 2 plus t by 2, and that remaining. So finally it is Vm sine of omega t ut minus Vm, here 2 pi by t, so it is this particular one, we can write it as 2 pi by t minus t half plus pi, if you are multiplying that entire factor. So I am just writing the complete expression. All these are the sign are missing, so right now the full expression is, you can write in this way, that Vm sine of omega t ut minus, here I am taking Vm as a common, so it is sine 2 pi by t into t minus t half plus pi. Sine pi plus theta means the sine theta, so same thing will be back, and with that multiplied of u t minus t half. So you can write in this way. And finally that sine of pi plus theta, all sine tan, so it is a room of tan, so their sign will be maintained as, but the sign will be minus, so minus and minus, it should be plus. So it is a final answer. Okay, so Another question we may discuss. So we can have few more problems like this. In one problem, this is question number 4, given as one waveform is like this. This is 0, this is A, this is B, this is C, this is D, this is E. Suppose it is given. So what is the expression for this? Now, how many boxes? Box number 1, 2 and 3. 3 boxes are there. So write the box function. First, G 0, A, first box of T, plus G B C T plus G D E T. These 3 are the get function, which is multiplied by, here the function is perhaps given as e to the power minus t, like this. So it is given in this question, that function. So you have to find out this is, so this is f of t. So you can easily evaluate this and find out that e to the power minus t, that is ut minus a plus this is ut minus b plus ut minus c, and plus for this, and so on. It is easy to solve. Now and the problem is given, say this is question number 5. So what is the problem? This is given as, say, in a particular graphical structure. This is quite like this. This is given as a t square. This is given as a 2 minus t square. So this is a t axis, this is a f of t axis. This is visible. So now they want to know what is the same word from all this. So here you have to know this particular point is, it is given in the question, that is 1, and in which point it touches, actually this point is 2. Okay, so it is very easy to say that 2 box function, that is 0 to 1 and 1 to 2. So it is ut minus 1 first box, and another box is ut minus 1 minus u. I'm very sorry, in this particular problem I have made a great mistake, that it should be a minus, and so on. Anyway, that is ut minus 1 and ut minus 2. 2 boxes are there that are being formed, so just multiply them with that particular function. So it is at square. So at square multiplied with ut minus 1 and another one plus a 2 minus t square whole square, that is multiplied with ut minus 1 minus ut minus 2. Okay. So you have to find out that what is the particular answer of this one. Say here you should split it in that 4 minus 4t plus t square in this way, and finally make some common, and final answer can be easily evaluated out. So out of such questions I can also discuss few more new one which I have very experienced in that my past few years of teaching. That suppose in a particular year one problem is given, zero, 1, 2, 3, and this is given as 5. Okay, so this is ft and this is given as t, right? Now the problem is given that suppose one inductor which is L equals to 3 millihenry. It means 3 into 10 to the power minus 3 Henry, or you can write it as Henry. Okay, so now this particular coil or that particular inductor should have one particular current flow like this. So it is an expression of IT for their reason. Current flow which is resting for, that is a second suppose, so 3 seconds up to. So what is a voltage induced in such coil? Express this entire thing with that kind of waveform with the particular value of indexing 0, 5, 1, 2 like this. You have to index that particular induced voltage waveform by that. So this type of question is also coming from this chapter. So how to solve it out? See, this particular part here, this particular part, the voltage is increasing, so it is increasing. So that is actually L di dt, that is equals to minus E or minus V, as you know by the property of inductor. So obviously where I is changing its slope very fastly to the positiveness, so obviously the V is increasing. Okay, so the V is induced. So what is the value of the V? So V equals to, you know, that L di dt. So here what is the value of that I here? I. So IT I can write by this particular waveform. You can see that IT equals to, in terms of Ft, as you know that Ft equals to what? It is a straight line. So what is a straight line? That is intercept 1, that is 5. So it is 5 by 1 into t. So it is 5t. This is a straight line. So I can write it as L di dt equals to L ddt of 5t, that is equals to 5 into 3 into 10 to the power minus 3 equals to 15 into this volt. So it is a millivolt range, right? So that is for 0 to 1 second span. So 1 to 2 second span, what happened? So in this span, what is the equation of this line? That is, I can write, that is step function. So it is ut equals to 5 step function, because it is a value of the step. So obviously V, say I should write that is V1, that is V2 equals to L di dt, where I is a constant, say 5, so L d dt of 5 equals to 0. Follow that? So it is 0. Again in 2 to 3 second, here V3 equals to L di dt, but here di dt is falling down, see, so it is gradually decreasing. So what should be? It is a minus section. So what is the value of di dt? Here you can, what is the equation of this straight line? You should find out if it is there. So it is the same 5 and 1, so the axis is shifted up to the 3 points, so it should be L d dt of that minus 5t. So it should be minus, cannot follow it, say minus 5t, so it should be minus 15 into 10 to the power minus 3 volt with the respect of time. So how to write this graph? Here you can see that is a graph. Here first 1, 2, 3. So that one slot T, you should make it at, say, this is. So this is, what is the amplitude? This is 15 millivolt. Well, so 1 to 2 it is 0. So it is 0. Here again the same for this is, and this is minus 15 millivolt. Okay, so this is the axis of T, this is the axis of Vt. Can it visible? Here the complete thing, as you can see, this is the final waveform. Just look like this: the first one, the second and third step. Okay, so now in my long career of the teaching, I have faced few new type of problem that is not usually discussed in that signal and systems chapter of the circuit theory book. Any book you can see, right? So one problem I have seen like this. I'm just discussing with you. Suppose that is the axis, this is 1, this is 2. So one waveform is given like this. So they are saying this is 100, 1 e to the power minus 10 t, and this is 100 into e to the power minus 10 t. These two signals are given. Now they just want to know that what is Vrms if it is Vt, if it is T. How to do this? Very easy. First of all, you have to do that. That is, what is the formula of this? This is Vrms square equals to 1 by T of that V square. That is V square. So that V square is an integrated form of 0 to T. Here it is 1 to 0 to 2. So what is the output? That is 1 by T, that is V square. So first of all, that is 100, 1 minus e to the power minus 10 t, that's whole square, that's whole square dt, integrated from 0 to 1. You can see it, plus you can write it as 1 by T, integration of 1 to 2 second, 100 e to the power minus 10 t, that whole square into dt. So if you are solving this particular equation, put the value of the t that is varying from 1 to 2, and there it is 0 to 1. So finally you will be getting it is as Vrms. Actually I have calculated it out, so it is finally coming as 65.2. You can write 25 blocks. This is the answer. Simply integrate it out and do this. Now if this type of problem may ask from some other area, so how to do this? In the same way, you have to find out the waveform. Say in a particular problem, say it is given, so what is the Vrms of such problem? Say it is 0, say it is 1, it is 2. So that is, here it is a span of t. So please integrate this particular function. Okay, you have to given this is, suppose this is a. So please find out the equation of the straight line. Put this equation of v square, integrate it out 0 to 1. You will find out what is Vrms. Okay, so in this way you can cover the different questions of the circuit theory, the signal and system part. So next part I will move on the Laplace transformation on the same thing, the same knowledge that I have shared with you, the same thing I will be applying in that domain of Laplace transformation in the next lecture. Thank you.